Welcome back to our third video of writing a convolutional neural network for image classification. In the previous videos, we wrote the model class. We also defined hyperparameters, device, model, optimizer, and loss function. In this video, we're gonna go through the data part, download the data, and just visualize the data and see what kind of data we're dealing with. And I'm going to talk to you about how important this visualization is because it helps you to create a strategy of the amount of transformations that you need to define on your images before these images could be introduced to your model. So these are important items that you definitely need to touch base before creating a strategy for your data set. And we're going to learn some of those here. So as I have mentioned in the top part of the notebook, the location of the data is known, and also the label is just has a link here. By clicking on them, they will be downloaded in your local drive. The data is the zip format, so you will download them, and they're 8,189 images of 102 different classes of flowers. So after downloading, you can simply, if you're using your local computer, you can simply introduce them to your model. I'm using a Google Colab, and Google Colab does not have access to my local computer. So I have gone ahead in advance and uploaded these photos from my local drive to my Google Drive. And now I'm going to write some codes that is going to teach the Google Colab to mount my Google Drive and be able to read that. If you're using your local machine, you don't need to write these codes. So let me just write it here, enabling Google Drive in the notebook. And I'm going to also write a note if you are using your local machine, these codes. And basically this is importing from google.colab. I'm importing drive, and this allows me to call drive.mount, and from there I'm going to say content drive. So if I run this, basically it will ask for permission, and I will give permission to this notebook to have access to my Google Drive. Once it has access, everything is resolved, and it might take a couple of seconds or maybe a minute or two, but then it will get access. While it is thinking, I'm gonna add another cell for, not here definitely, I'm gonna add another cell for codes, and I'm gonna go ahead with writing the next pieces of my data visualization. So in this case, my data path is going to be defined. This is a path to my data. In this case, I'm using content, and don't forget to have a slash here, backslash here. So I'm gonna define from content and then drive, and then I'm going to my drive. This is how Google Drive is introduced, and then I have made a folder 102 flowers, and that's exactly where my images are located. If this is your local machine, you will basically, if you're using a Windows machine, you will start by your drive C. Like for example, you can go like let's say the images are in your drive C, so you go like this, and then the path to the flower images, and yeah, if this is a Mac, you will address it the same way, but you basically get to the path where the images are located. Next, we're gonna need the label path, and for that I'm using the same folder. So if you think about it, in the same folder I have uploaded both the images and the label, and the label is called image labels, and the format is a .mat. Mat is a format of matrices in the MATLAB language, and I will show you what kind of package you need in order to be able to open a .mat file. And basically the package that we need right now is the SciPy package. So we're going to import SciPy, and from SciPy we need scipy.io, as I will import it as SCP, and we also want to have some image visualization. So let me just import matplotlib.pyplot as plt, and we're gonna also read the label matrix. We might want to make a data frame, so let's just import pandas as pd, and most of the time when we need pandas we might need to do some matrix calculations, so let's just import numpy as np2. Okay, so next is to open this image labels.mat, and what I'm gonna call it is just basically, this is gonna be an array of labels, and I'm gonna use the scipy.io and .load mat, which is one function under scipy.io, and I'm gonna go like label path, and when it gets open, it will be a dictionary of several different items or several different keys. One of them is labels. Since it's coming from the MATLAB and I'm working in Python, everything starts from 1 in there. In Python, everything starts from 0. So I'm gonna basically subtract number 1 from all the labels so that everything becomes Pythonic. After doing that, what I need to do is to basically generate random numbers pointing out to the number of the images, and then from there I can basically go ahead and open up my images. In order to open the images, obviously we need to know how they are named and what is the file name of every single image. So let's just do a quick os.list there, and it's basically list every file that is under a specific directory, and in this case I'm gonna list everything under data path. So let's just run it. Oh yeah, so the OS package, we didn't import it, so let's go to the top and import the OS package, and now I should be able to run this. Okay, so as you can see, the images look like that they have a very consistent way of naming. It starts with image, an underscore, and a 5-digit number that starts from 1, and obviously there's like 4 zeros and then 1.jpg, right? And yeah, we can check whether it starts from a specific value or not, and the way to check it is to basically have it sorted And once it's sorted, we're going to have its element 0 printed out. So the element 0 is 4 zeros and 1.jpg. And this is important because right now I know how the images are called. Now, my point is to generate 8 random numbers in the range of the number from basically 1 to 8,189, and then this way I would basically call those 8 images associated to those numbers and represent them. In order to do this, let's start by, I'm going to make this a comment so that you would have access to this code as well. But now I have to make my figure. So the way we represent the figure is that first you make the canvas, and after you make the canvas, you basically put the images into your canvas. So I'm going to make my canvas here, and I'm going to use matplotlib for that. So under matplotlib.pyplot, there's a subplots, and subplots basically allows us to have multiple panels within one figure. And I'm going to say I'm going to have 2 rows of images, 4 columns of images, and I want the fixed size, the final fixed size, to be 8 by 12 inches. Next, I'm gonna generate random images in the range of 1 to 8,189, and in order to do that, I'm gonna basically make an image num, and I'm gonna use the random package. So I need to import the random package. If you have Python installed, you automatically have the random package installed, so you don't need to be worried about installing the random package. But random.sample from a range of 1 to 8,190, because it's 1,089 images, and the range function does not take into account the last number. And how many sample do I want? I want 8 numbers randomly generated in this range. And it will become a list, image num will become a list of these 8 numbers. Once I have that, I immediately define a for, and I would say for I in range of 2, and I is the number of rows, for j in range of 4, and 4 represents the columns. Now I'm going to have my image load. In order to load the image or read the image, I'm going to utilize the skimage.io as a skio. A skimage is a very useful package for handling images. It's the sister package to scikit-learn, and people who have done machine learning, they know how robust is the scikit-learn. Now this sister package scikit-image or skimage is basically developed to analyze images, perform manipulations, filtering, and different sort of transformations on images. One of these things obviously has to do with opening the images, and that is what I'm going to use to open these images. And once it's opened, it's going to be a NumPy array, and it's going to be saved under image. We first need to open an image so that we could visualize it, and that's exactly what we are going to do. skio has an imread function, so I'm going to use that. And then now I have to make the path to the image. In order to do that, I have to add the name of the image. This strings needs to be added to this. In order to do that, I'm going to use the os.path.join function, which whatever items it gets, it attaches them together with backslashes. So definitely data path is one item. And the next item needs to be a string like this, but I need to put in the number that is randomly generated in here. So for that, I'm going to use an fs string. My fs string is going to be image, an underscore, and then a value. And this value is going to go into these curly brackets. And that is my image num. Image num has 8 elements. Which element? And that element is basically I times 4 plus j. You can do the math and you will see that whichever the I values I and j will have, this represent a distinct number from 0 to 7, given the values of I and j. So this nicely iterates through the different components of image num, but we have one problem, and that is the fact that image num is going to be, for example, 4, and what is going to be generated here would be image underscore 4.jpg. I want 4 zeros before 4, but if it's 14, I want 3 zeros. So that's an important thing to handle, and the way we handle this is by putting a colon, and then I'm going to say I want 5 number of zeros. If you already have 2 digits, only put 3 zeros. And then I will continue it with the formatting of the image. So now it should be fine. It will read my image. After reading it, now I'm going to tell the ax, or basically axis, to put it into the canvas that I made. Ax, I, and j is, ax, im show of the image. After doing that, we're going to have x, I, and j. Now, it will show it, but what it will show is, oh yeah, so skio that we added here, we didn't run it. So let's just run it, and now we'll read it. I have several problems here. One of them is a typo. But after that, we're reading the images, and now you'll see that for some reason we have axes here. We want to get rid of them, so let's just get rid of them immediately. In order to get rid of them, we will do xij dot axis, and we flag it as off. And if we run it, obviously we're going to have 4 other images open. That's exactly the case, and the axis is off. Now, what I would like to be able to show is putting the label and the number and the class of the images on top. So what I'm going to do is to set titles for every single image here. So x, I, and j dot set title. And now I'm going to use another fs string that is going to say basically what is the label. And in this case, the label is label r of the image num I times 4 plus j. That's exactly going to point to the label of the very same image. And once I did that, I'm going to run it. There's a problem here, and it says, oh yeah, so we opened the curly bracket, but we didn't close it. So yeah, so perhaps it's one row and multiple it's one row and multiple columns, so that's why we need to have a 0 at first, and now we can see that, for example, we have images and then their label, obviously it's different. That is good for now. Let's just think about why these images have this amount of distance between each other. A part of it is because it's an 8 by 12, so maybe the height of the image could decrease. I can decrease it to maybe 6 to the half of this height that I had associated the image with, and now we can see how nice this image looks like. One important thing that I mentioned at the beginning is that visualizing the raw data that you have allows you to decide what exact strategy you need to put forward for the transformations of your images. Remember that convolutional neural networks expects all the input images that you have would have the same dimensions. So here, the first thing I see is that I don't have the same dimensions in my images. There's usually two strategies here. Number one is to crop these images in a way that all of them get the same dimensions. That's requires a little bit of time in order to figure out what's the right size of cropping and selecting the center pixel and then grow the crop from there. But the easier thing to do is to perform scaling. Every image could be descaled, or a scale of them can be changed, and then they would basically become the same width and height that we want. It has some downsides, and one of that is the fact that the scale of the image would be broken. So the images, some of them wouldn't look as they normally do, but the upside of it is that we wouldn't lose any information, whereas in cropping, we would lose some of the information, and that can be detrimental when it comes to extracting necessary features from images. We might lose some features. So in this case, I prefer to scale the images rather than center cropping. So that is exactly what we are going to do. And before going forward, we gotta do one more thing, and that is the fact that later on, in order for us to be able to make a data set on these images, we would need a data frame, a .csv file that for every single image has a single row, and in one row it has the path to that image, and in the next row it has the label of that image. So I need basically a data frame of 8,189 indices and columns being path and label. So in order to make this, I'm gonna basically start by writing a list. First, I will make a list of those arrays, and then I will make a list of the path, and then I'll make a simple data frame from a dictionary that I will make from those. So in order to do this, I will make a labels list, and that will be the list of labels are, I believe it's label, not labels, label R of first row and all the columns. And then I will have image path list. And keep in mind, I have to sort everything because here in here everything is sorted. So I will do the same thing. So I will use the sorted of the thing. The package that I will be using here in order to get the complete path of all the images is the globe package. It's very useful in reading the full path of the data files within a specific folder. So obviously I'm going to call sorted. I want them to be sorted so that everything, the order here matches the order in the labels list. And then I'm going to use globe.globe of os.path.join of data path and a specific type of a string that is basically everything that has a JPEG format I want to be listed. Once this list is made, I make a metadata data frame, which is a pd.data frame, and I'm making a data frame out of a dictionary. And the way to do it is to open up a dictionary, then name the column header, that in this case is image path, and then say what list I want to be under that. And this is image path list. And then the next header is image label. And I want this to be labels list. Once it's made, let's just take a look at metadata. So I do have metadata created, all the images sorted, and everything with their labels are located here. So at this point, our job at this video is done. We mounted our Google Drive, and then we were able to basically open up the label path, open up the images, look at the images themselves. We also labeled them, and we strategized our approach towards creating a data set and necessary transformations for these data. So I'll see you in the next video where we're going to write a PyTorch dataset and a data loader around these images. I'll see you there.